Good evening, friends. Today we are discussing on crashing the given project. So here there will be two times, that is normal time and crash time are given, and two costs, that is normal cost and the crash cost are given. And it is also said that the indirect cost is 70 rupees per day. So whatever is the number of days consumed for completing the project on each day, so an additional overhead cost of 70 rupees will be spent. So now for the given data, we'll write the project network, and we are writing the earliest start, earliest finish, late start and late finish. So that we already know. So the project normal duration is estimated here as 18 days. The critical part which is highlighted with double arrows. So that is 1 to 2 and 2 to 5. So the cost of the project is now nothing but the summation of normal cost plus the indirect cost. So here you take the sum of all the normal costs here. So that is the summation of normal cost that comes here, and indirect cost. So per day it is 70 rupees. For 18 days it is 70 into 18, it comes to 1840 rupees. Now we will see how to crash the project to reduce the project completion time, and we'll see what is the increase in the cost of the project. Now there will be two activities which are considered as critical, for which the cost slope is written. So what is the cost slope? So that is here, if you take an example of activity 1 to 2, if you go in normal speed, it takes 8 days, and the cost of doing this particular activity is 100 rupees. If you increase the speed, so it will be completed in 6 days. That is, I can reduce this activity by 2 days, so that this particular activity will be over in 6 days. But so I have to spend 200 rupees. So increase in the cost is now 100 rupees. That is for 2 days. So I will reduce the duration of this activity by 8 minus 6, that is 2 days, and the increase in the cost is now 200 minus 100. So that is difference in the cost is now 100, and the difference in the time is 8 minus 6, so that is 2. So 100 divided by 2 is 50 rupees. So I am spending 50 rupees additional cost. Uh, because I want to reduce my project completion time. So if this particular activity is reduced for 2 days, the increase in the cost is 100 rupees for 2 days. So it is 100 by 2, so that is 50 rupees for 1 day. So that is written here. Similarly, the critical activity 2 to 5. So the cost slope is 60 rupees. So whatever is the number of critical activities given here, for all the critical activities, write the cost slope. So take the minimum cost slope. Here we have only two critical activities. So this activity 1 to 2 is having the minimum cost slope, that is 50 rupees. So project completion time. So we are reducing this particular activity 1 to 2 by 2 days. So project completion time is now 18 minus 2, so that is 16 days. So the critical path remains the same. So that is 1 to 2, 2 to 5 only. So that is okay. Earlier this was 8 days. Now it is reduced by 2 days. So 8 minus 2. So that is I am going to do this activity in 6 days. So this path now takes 6 plus 10. So that is 16 days. Now the next critical activity is 2 to 5 in the table here. So that is having the cost slope of 60 rupees. So by the given data, so this particular activity 2 to 5. So I have the normal pace of 10 days. If I want to crash this particular activity, so it will be reduced to 5 days. So it is 10 minus 5, so that is 5 days. So I can reduce that particular activity 2 to 5 by 5 days. So if you reduce this particular activity by 5 days, so the duration becomes 10 minus 5. So that is 6 plus 5, it becomes 11 days. But the other path which is having non-critical activities is consuming 12 days. So this becomes critical now. So we cannot reduce this 10 days to 5 days, reduce by 4 days, so that it becomes 10 minus 4, so that is 6 days. So this becomes 6 plus 6, so totally it is 12 days. So that the path 1 to 2, 2 to 5 is also taking 12 days, and this particular path 1 to 3, 3 to 4, 4 to 5 also takes 12 days. So now we have two critical paths now. So the available crash time on the path 1 to 2, 2 to 5 is completely used. Here I have reduced this particular activity by 1 day, and here this particular activity is also reduced by 1 day. If you take the activity, so that is 4 to 5, so you can reduce this particular activity by 3 minus 1, so that is 2 days. But if you reduce that particular activity 4 to 5 by 2 days, so it becomes 3 minus 2, so that it becomes finally 1. So if you take the sum here, it becomes 4 plus 5 plus 1, it becomes 10 days. But this is the critical path now. So I am not reducing this by 2 days, so it is reduced by 1 day. Earlier it was 3, reduced by 1 day, it becomes 3 minus 1, so that is equal to 2. So totally it becomes 11 days. Now these two paths which remains critical now. So further crashing of the critical activities is not allowed. So hence the project completion time is calculated as 11 days now. The cost of the project is now 990 plus this indirect cost. So the indirect cost is 70 rupees per day. So project completion time is now 11. So 11 into 70 becomes 770. So now this is the direct cost. So this direct cost is the summation of the normal cost plus the summation of increased cost. So only wherever I have reduced the days, so we have the increased cost. So this particular activity is completely crashed. So we have the increased cost. So for reducing the project by 1 day, it cost me 50 rupees. So for 2 days, it is completely used. So it is 50 into 2. So then this particular activity, so all the 5 days are crashed here. So for 1 day, it is 60 rupees. So 60 into 5. So the increased cost is now 60 into 5. Here 2 days are allowed, but I have reduced only for 1 day, so it is 10 into 1. So the summation of these three plus the summation of the normal cost, it comes to 1760 rupees. So earlier it was calculated as project completion time is 16 days, and the cost is now this. But now the project completion time and the cost, final cost of the project is this. Thank you.